I think let's call Susan up and let's start with her presentation, and then maybe what we'll do is we'll open the questions to the floor afterwards, and we can interrogate her. Over to you. I'll put a bottle of water here.
Is there slides?
I hope so.
Okay. All right. As he said, I'm Susan Forney from Hurricane Electric. I also am a member of the board of directors for the North American Network Operators SAFNOG in the US. And I used to work for a small software company in Redmond, Washington, Microsoft, of which you may have heard. I'm here to talk to you today about Peirong economics. And what I want to talk to you about is 5 topics. The first one being why Peirong is an investment. And the reason why Peirong is investment is that Peirong is not free. Oh, it looks like I'm getting my slides here. Okay, here we go. All right. And the clicker might work. Oh, there we go. All right. That's okay. So these are the topics I'll be talking about: why Peirong is an investment, when Peirong is worth the investment, assessing the impact on your network devices, why you need a Peirong strategy, and why you need Peirong security. So let's start talking about why it's an investment. Next slide. So Peirong is a connection between 2 network devices. Network devices require an investment of cash, and they are not free. People are needed to configure and maintain your network devices. They are not free. They expect salaries. I don't know why. Network devices need electrical power and a space to occupy. Those are not free either, so which is clear for your co-location bills. So we've established that this is going to cost you something. Peirong requires an investment, but as with anything with a cost, it also has a value. And to determine its value to you, you need to think about what it's actually costing you. So first, what are your ports costing you? Don't forget your optics and your equipment support costs. If you put a port on a router versus putting a port on a switch, that's a bigger investment. Router ports are generally more expensive than switch ports. Consider where the costs for connecting to what the costs are for connecting to the Peirong exchange, including the cross connects at the data center, exchange or circuit costs that you're paying for a third-party provider to reach the IX. And don't forget the setup fees, because those add up. And then now that we've considered these things, I have a little chart prepared to kind of look at the numbers to prepare us for a little discussion on what it costs. And I did this in euros, and I did this in round numbers. Your mileage may vary, but this is a chart that compares an ISP versus an internet exchange, my-IX. And if we look at the device port costs, of course, they're the same. No matter what port you use, it costs the same. And I'm guessing that about 200 euros is an average port cost. The setup fee for your cross connect, most data centers that I looked at were in the neighborhood of about 500 euros. And then the setup fee for an ISP service might run you maybe 250 euros. Maybe at IX it was a little higher. Some of them were like 500 euros. If we look at our recurring costs, the things we're going to have to pay every single month, we're going to have a commit level. In this example, I'm assuming a 10 gigabit port, and my commit level for 10 gigs for your transit provider is going to be 2 gigs or 2,000 megabits. For commit price, I did a nice handy round number of $1 per megabit. So we have 2,000 euros a month for a commit. And then if we burst above that, our ISP is going to be generous and just charge us €1 per megabit to make the math easier. There's no price per port, of course, and the cross-connect fee is about $250. Now, on the recurring cost for the IX side, things are looking pretty good. Your price per port is maybe about $500 a month, and your cross-connect is costing you $250. So right now, we're looking at the numbers. The IX is looking pretty good. And think about that chart, because there will be a test later. it's time to assess your benefits. And to make the best investment, you should consider who your potential peering partners will be on the network. Exchanges where you can reach cloud providers like or content networks can be very advantageous, especially if they are people that you buy services from. For example, if you are using Google Office tools, or you're using Microsoft Office tools, or you are an Amazon cloud provider or Amazon cloud customer, or in this neighborhood, maybe a Liquid cloud customer, being able to peer with any of those networks would be extremely advantageous. You would be directly connected to them, and you would save all of those costs on your transit port. Don't forget to peer with caching networks like Akamai, Fastly, and Limelight, because a lot of the bits that your users consume go straight to those caching networks. And if you're peering with them, you're going to save a lot of money in transit costs. And lastly, if you don't really know where your traffic is going for sure, NetFlow or SFlow can give you a lot of information about what's going on in your network. An example I'd like to use is a university I helped at one point tried to connect to an internet exchange, and they were trying to figure out who to peer with. And so we were thinking, oh, well, they're a university, they're going to peer with research networks, and they're going to have some business for their admin office. And, so the normal types of websites, search engines, those are the kind of things would be advantageous, right? So we set up some SFlow and took a look at their network. And this university provides internet connectivity for its dormitories. And we were very surprised to discover that over 75% of the university's traffic was going to streaming sites. So the best peering partner on this particular exchange for this university was Netflix. That was where they were going to save money. Sometimes those surprises are out there. It pays to know so that you can get the biggest bang for your buck. And hopefully run next slide. Okay, so once you have this information, you can see whether getting that port on the exchange is going to make a good business sense based on cost. And it's coming up. Okay, so our first slide shows us, if we just look at what we were talking about before, remember that last slide I had a little chart? This is an example of that chart. It goes from about 500 to half a gig basically to 8 gigs. And it shows us the cost per megabit based on whether I'm using the transit, which is that shown by that blue line, or the internet exchange port. And as you can see, the internet exchange port never quite goes to free, but it comes really close. We're down to, by the time we get to almost a full port, we're at cents per megabit. So that's looking good. So obviously this is a slam dunk, right? But the problem is that not even Hurricane Electric, and hopefully this slide comes up, the problem is that not even Hurricane Electric can get all of its traffic off of peering. We need transit providers. So we're going to assume, for the sake of, again, simple math, that I am able to put half of my traffic on my peering port, which leaves me with half of my traffic on my transit. And when I do that, that blue line in the center becomes my cost. That's my average cost of 50% of the traffic on the IX, 50% of the traffic on the ISP. And as you can see, it's still looking great. If I had all of my traffic on a transit port, this blue line is still lower, right? So it should be simple. However, there's one more thing you have to consider. The problem is that you still have that pesky 2 gigabit commit on your transit port. And until you get to about 4 gigs of traffic, in this example, half on your transit port and half on your internet exchange, you are still paying the ISP for traffic you're not using, because you're paying for that 2 gigs, whether it crosses the port or not. So when you are putting traffic on the internet exchange, it pays to think about these things. You have your contracts in place now, but your strategy moving forward might be to go with a little less money at the ISP and a little more money at the exchange, if that's going to save you money. So next slide. Now, don't forget to factor in operational costs when you are thinking about setting up all these peering groups. It's going to cost money to maintain them. You can pre-configure peer groups for your neighbors to make the setup quick and easy, so it doesn't take you a lot of time and energy to turn them up. And consider the support priority of your peers. and when you're pairing with a lot of people on an internet exchange, you might not want to wake up your network engineers in the middle of the night because one of them goes down. Now, in the case of the university that was pairing with Netflix, this might be all hands on deck. But for most of them, I'm thinking that you might not want to do that. Monitor your port capacity on the internet exchange and increase it before you get in trouble. Bits fall on the floor from internet exchange ports just the same way they do on overloaded transit ports, and then the whole idea of getting a better performance goes out the window. So next slide. All right, so having said all of that, it's not all about the money. Peering can provide benefits in terms of reduced latency and improved throughput. When I worked at the Boston Internet Exchange, which I operated in my last job, I had people that were coming to the exchange simply to peer with Amazon and Microsoft, because the proximity to those services, being in Boston, everything goes through New York. And if they went on the internet exchange, they went straight to the provider network. And so it saved them a lot of latency, and it also was very dramatic in terms of performance, because a lot of their applications weren't very latency tolerant, and it helped them a lot. So in addition to that, if you're peering with people, you're going to get more diversity at the edge. You're going to improve traffic flow, decrease the latency, and your routers can rebuild their tables faster because all your eggs aren't in one basket. You can improve the growth and scale of your network by peering with people. And lastly, your internal and external customers are bound to be happier with your better network performance. Next slide. So after weighing your costs and against your benefits and choosing potential peering partners, it's time to consider what is going to happen to your network devices when you start adding all of these peers to them. Additional routers mean routes mean bigger tables and more memory usage. Routers are built to handle both traffic throughput and routing tables, but routers don't have infinite capacity. That's why they make more than one of them, and why they sell more memory, and they make bigger routers. So they want you to take this into consideration when you're thinking about peering. Networks have different replacement rates, but an average is around 5 years for a router. So if it's coming up time to replace your router and you're thinking about joining some exchanges, you might want to think about all this stuff before you buy your next piece of equipment to make sure you're buying something that is sized correctly. Next slide. So to give us an idea about how that might work out, it's going to help you to take a look at the IPv4 and IPv6 routing tables and what the growth of those are. I found, and I list the link in the resources slide at the end of my presentation, I found someone who had predicted the size of the internet routing table in 2017 up to 2022. And it actually was pretty accurate. 2 years down the road, we can see that their projections were pretty similar. You can see that the blue line behind it, which is the projection, and the orange line are basically on top of each other. So the internet IPv4 table is growing about 10% a year. And you can see that it's set to reach about 800,000 routes, by the end of this year, and it's on track to do that. Next slide. The IPv6 one was a little more interesting. The blue line shows the trajectory of what they were predicting in 2017, and I corrected the data for what actually happened as of this year. And as you can see, the IPv6 table is growing a little bit faster than expected. Still not dramatic. It's not like it's going to catch up with v4 next week, but there is a few more routes coming on, and we're adopting a little bit more v6 a little bit faster than they had anticipated. I left the projections out where they were because I didn't want to be arrogant and think I could predict where IPv6 was going without any data. Next slide. So now now that you know where the routing tables are going, you need to consider the fib or forwarding plane on your router, which is where all your best paths are stored. If the size of the IPv4 and v6 tables are going to determine how much fib you need. And when we looked at the forecast that we saw for v4 and v6, you can see that it's growing fast, and it's approaching 1 million. It's quickly approaching 1 million routes in your table. The best case scenario in fib storage is that you'll have a 1-to-1 ratio. That's true for IPv4 routes. In some manufacturers, IPv6 routes are going to take twice as much space as an IPv4. So I've created another graph to see how this is going to play out. Next slide. So the blue line is the projected IPv4 routes. The orange line is projected IPv6. And then the gray line is projected fib space based on a calculation of 2-to-1 for the IPv6 routes. And as you can see, sometime between 2019 and 2020, that is going to hit 1 million routes. So if your fib only supports that, you might want to consider that before adding other routes for your peers, because your internet table is going to take up most of that space. Next slide. So as I just pointed out, it might not be good news if you're limited to 1 million routes, but we do have a little bit more math to do. The IPv6 table today is a little over 70,000 routes. And if we multiplied it by 2, you can see down there that we're at 940,000 routes, more or less today, with the internet IPv4 table approaching 800,000 routes. So it's getting really close. Next slide. If it's 1, of course, we're at 800. You're one of those vendors where it's 1, you're at 870, and you have 1,000. You have a little more breathing room. It might not take that long to get to 1 million routes if you're accepting a lot of disaggregated internal routes, your point-to-points, your loopbacks, customer routes in your network, or if you have a lot of peers who are advertising more specific routes to you than they do to the internet, which they do sometimes. And if you need to have multicast, MPLS, VPN, or L2 VPN routes in your fib to support other services, those are also going to eat up space. Those are the things you need to think about. Next slide. So if you have adequate hardware to accomplish this, peering with everybody in the internet exchange, you're also going to need a strategy. A peering strategy is going to help you squeeze the most value from your exchange port. And some of the things we are going to consider are what networks would benefit you the most, what exchanges should you join, and how will you route the prefixes you receive in your network. Next slide. So you might want to evaluate what your potential peers can provide for you. And the criteria you want to consider are, do you send a lot of traffic to this peer over a transit connection that would save you money to, or latency to send over your peering connection? And do you have excess bandwidth on your IX interface? And this is important because a lot of people turn peers up and forget. And some peers can send you an awful lot of traffic. You know what's going to happen because you can see from your net flows or from the load on your interface now, how much traffic you have. So it's pretty easy to calculate if you're going to burst over that. And if you just pay attention, then you won't have any nasty surprises. Next slide. So to demonstrate why a peering strategy helps you out, what I have done here is I've created a little diagram, and I have a green company, and they're connected to the internet and to their satellite office, which is in another country. And their satellite office is connected to the internet also. They've got a router in there. And the satellite office likes to do a lot of traffic with the blue network down below. And so right now, this is a good scenario for the satellite office. They're close by to the blue network. They're closer than the mothership, and this is working out for them. So then what happens, next slide, if the green network decides to join an internet exchange and peer with the blue network? Well, if you're not careful, all of that traffic for the sales office or that satellite network in the other country could start going through the internet exchange, and that would actually reduce performance. So pay attention to the people that you're peering with. Pay attention to where their routes go to make sure that when you turn up a neighbor on the exchange, you haven't actually made things worse. Next slide. So as we have seen, peering can improve your routing and reduce your latency or not. And if you peer with someone at more than one location, consider a routing architecture that allows your prefixes to be announced strategically to keep your traffic local. Obviously, if you have a big backbone, this might not be a consideration, but for some of the smaller networks, it's definitely something to keep in mind. Start by adding the exchanges appearing on the exchange that can do the most for your network. and you'll get an return on your investment a little more quickly. Next slide. So now we're going to talk about why you need peering security. Peering works when it is a good experience for both parties. So first, clean up your advertisements. When you peer with somebody, you should not be leaking your private IP space or routes that do not originate from a public AS to your peers. When you do this and they see those sneaking across the peering session, they start to lose confidence in you. And you don't want that. You want them to think that you are a good network operator and very competent. Be easy to contact by keeping up-to-date information in Peering DB or at your RIRs. This is just, a good practice. And keep your IRR records up to date. This is a lot more important than it used to be. More networks every day are refusing to accept routes that have invalid IRR path records or invalid origins. And this kind of sneaks up on people, especially if you were working with an internet provider that allowed you to do a letter of authorization and you've had routes that have been in place for a very long time. You might discover that actually those routes aren't reaching their destination because now people are not honoring them. Networks like NTT and Telia, for example, will drop those routes at the edge. So while your provider's accepting them, these networks where your destination traffic is might not be. So make sure that you keep that up to date. And also create route origin authorizations ROAs for all your prefixes and update them on a periodic basis. RPKI is coming, and it's better not to have to do all of this at the last minute and scramble to get everything corrected. Do it now. Keep it up while you add prefixes to your network, and life will be a lot calmer. Next slide. While your peers on the Internet Exchange might be perfectly fine people, I advise you to trust no one. Set maximum prefix limits for your peers. No one ever means to leak the entire internet routing table to you, but it happens. So make sure that you have maximum prefix limits in place so that the session will be shut down and you won't be adversely impacted by this. Filter your routes so that you're only accepting routes from a valid peers AS and deny private IP space and bogons. While you should be very careful not to be advertising those things, you should not allow yourself to listen to them from others. And don't forget to suggest to check services so that you will be able to see blocked prefixes and not accept them. Also, consider using AS path filters to ensure that your peers are not leaking routes from their upstream providers. You shouldn't be listening to routes from a peer that is from their upstream. And for those of you who think, oh, I can't filter those routes, it would be so hard. It actually is very simple. There are a lot of ways to do it out there. One of the tools I like is BGP-Q3 because it is so simple. You can actually install it on your laptop and check to see how easy it is to build these filters. And you can script it so that these happen automatically. You might want to update your filters every day, every week, whatever makes sense for your network. But in this example, all I've done is just type in BGP-Q3 on the command line, -J for Juniper, -6 for IPv6, and L, which tells me that the next thing following is the name of my prefix list, and then the AS number that I want to check. And then it immediately generates a filter for your router, and you can just paste that in, and there you go. You don't have to worry. All set up. So your IX port exposes your network to security risks that are inherent anytime you connect something to a layer 2 port. So don't connect your port to an internet exchange with the default configuration. A lot of ISPs have recommended configurations that they post on their websites. HKX, AM6 is those are two good examples. If your IX doesn't do it, you might want to borrow the recommendations from there to make sure that you've locked your port down. Most IXs are only going to allow unicast traffic. IPv6 neighbor discovery is going to be the exception for multicast. And next slide. And because the IX LAN has next hop addresses when you're peering with people. It's not uncommon for engineers to route the LAN prefix inside their networks. Obviously, you want to be able to reach that next hop. However, it is not internet routed IP space, and it does not originate from your AS, and you should never advertise it externally. However, this still happens, and next slide's an example. Here is the prefix for, I think it's JPNIX, I'm blanking on which one this is. You can see that while it does not have a valid ROA, while it does not have a valid origin, we still picked up an advertisement of this /24, and it's actually /23, on the internet. So if someone wanted to take advantage of an attack vector and attack those addresses, now you've given them a way to get there. And worse, it's going to go through your network. So if someone does decide to take advantage of this, it's going to overwhelm your port. So don't do it. Next slide. And the last part about peering security is be responsive when you're notified of an issue. Nobody likes a peer who ignores them, especially when something awful is happening like DDoS or phishing or anything else that people can do wrong that you don't like. Especially in Southern Africa, this is important because you are experiencing a quick rise in the number of people who are participating in the internet and becoming users. And those users are inexperienced and they're more vulnerable to these things. So do everybody a favor and shut this stuff down really fast before people can take advantage of people who don't know any better. No one can take advantage of you without your permission. Just control your advertisements so that doesn't happen. And even if you do everything right, not all networks are going to want to peer with you. And this usually has something to do with their peering policy, doesn't have anything to do with you in particular. I would advise you to keep asking people if they say no the first time. They might be saying no because they don't have capacity on their port, and later on they might have it. So, hey, they might say yes, or they might change their name, their mind about you and your network. Who knows? Bake them a cake, it might work. Anyway, that's all I have for you today. Do you have any questions? It's not going to the next slide. It's just the last slide, but.
Hi, Greg from Smart Technology. There's been a lot of buzz amongst some of the local ISPs about de-peering with Hurricane because of capacity issues, stuff like that. The same on V6. A lot of local ISPs are using the V6 transit, and they're also reporting throughput problems, things like that. Are you aware of kind of what the local ISPs are saying about Hurricane?
Yeah, I am. And of course, nobody's perfect. And we always try to increase our capacity and address those issues when they come up and run the network the best way possible. We don't want to make people unhappy. So we do everything we can to address those issues. And I haven't noticed people de-peering with us, but I'm sure some people do. Good.
Just one final thing. The IPv6 certification that you run on your website, it's actually very good. So people in the audience here, Hurricane Electric's done a lot of work with their IPv6 certification. It doesn't certify that you know how IPv6 actually works. It's more to test your environment. So I encourage people that are doing V6 to actually take a look at it. It's like I said, it's not to test your knowledge. It tests your environment, and it's actually quite beneficial. Thank you.
Thanks. We also have two mobile app tools that might be useful. We've got a mobile app tool for network tools that does things like trace routes and pings from your app if you don't have something else that does it. And we have a bye-bye IPv4. So.
Susan, thank you very much. I think some of the things that I took out of that talk is trust no one, and make sure that when you're doing your stuff, do it right. And I think the most important thing is if you are peering at an exchange point, as Susan mentioned, if you're able to do everything correctly on your side, then and do the inbound and outbound filtering correctly, you make the experience better for everybody else at the exchange as well. Susan, thank you very much. Quick show of hands in the room. Who has an IPv6 network that is currently running? All right. Who would want to find out more information about running an IPv6 network sitting in the room? Just 4 or 5 hands? There we go. There's some more hands. Excellent. What we do at INXZA, for example, is we run workshops that happen around certain areas. And I think if you guys are interested in finding out more about IPv6 and training and things like that, come and chat to us. We do workshops in Cape Town, Durban, Johannesburg, all sorts of things like this. And there are guys that are able to help you with how the thing works and sort of kickstart you into getting more IPv6 running on your network. Our next speaker is no stranger to conferences, and he also happens to be the manager of a large exchange point in South Africa. The exchange point that he manages is the INXZA one, the t-shirts that everybody got. His name is Nishal. His surname